Hello, this is Ms. Schwartz, and today we are going to be revisiting velocity and acceleration and figuring out how forces fit in with those two things. So you should remember from last chapter that there is an interaction between the sign of velocity and the sign of acceleration, which tells you what is happening to the motion. This chart might look familiar. If you recall, when you have the same sign, so for instance, a positive velocity and a positive acceleration, it means the speed is going to be increasing. When you have opposite signs, that means the speed is going to be decreasing. And the sign of the velocity tells you what directions happen, what the direction of travel is. Now, if we look back at this, down here you may not have noticed that there is the term net force. Now, a net force is a total force is acting on an object, gravity, normal, applied, friction, etc. When the forces are equal and in opposite directions, they are said to be balanced. That's our blue box down here. When the forces are not equal, the forces are unbalanced, and therefore there is some kind of net force, and that's our red one here. So you have 10 newtons to the left, 4.5 newtons to the right, so you have a total net force of 5.5 newtons. The thing about net forces is when for an object to accelerate, there needs to be a net force. So we can actually look at this and change it from velocity and acceleration to velocity and forces, because the forces are actually what causes the acceleration. So the direction of the force tells us the direction of the acceleration. So what does this mean? So we have this free body diagram, and we can see that there is a net upward force. So there is 1 unit higher of an applied force. But just looking at the free body diagram doesn't tell us anything about the motion. We know there's an acceleration, but we can't tell if the object is speeding up or slowing down. We need to know something about the initial state of this. So let's use this free body diagram and talk about a parachute. So when we have a person skydiving, they're falling downward. So the velocity is in downward motion. When they open the parachute, the net force is an upward motion. So that means that they are traveling downward and they are slowing down because you have a net upward force with a downward velocity. Now, this could also be looked at in terms of a weightlifter. They would be the same free body diagram. So let's start with the weightlifter having the weight on the ground, which means the velocity is 0. She applies a net force up. Therefore, the object is traveling upward and is speeding up. Now, this same thing will occur if we're in this transition where she is changing from pulling to pushing. So the velocity is an upward velocity, and the net force is up, and therefore the weight is traveling upward and is speeding up. When forces are balanced, we said that there is no net force, therefore there is no acceleration. So the object is going to continue doing whatever it was doing originally. So if the object was still, it's going to stay still. If the object was moving, it's going to continue to move at a constant speed. All right. So to sum up, when you have balanced forces, all the forces cancel each other out and the net force is 0. The forces are said to be in equilibrium. There is no acceleration, which means there is no change in how the object is moving. If it was still, it's going to stay still. If it was moving, it's going to stay moving. When forces are unbalanced, there is a net force, so a net force greater than 0. There is an acceleration of some kind, but you need to know how the object is originally moving to figure out if it was speeding up or slowing down. I hope this helps you out with part 3 of the concept builder. If you have questions, please feel free to post them into Classroom and I will get to you as soon as possible. All right. Have a good day.